So we have the system of our girl, which involves the mass, gravitational potential energy, elastic potential energy, and kinetic energy. We know that the mass of the girl is 52 kilograms, and there's no outside work being done on the system. So we use the conservation of energy, which equals kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. We chose for the initial to be the top and the final to be the bottom. In our initial, we know that there's no kinetic energy because our velocity is 0. There's no elastic potential energy because she's not in contact with the spring. So it's gravitational potential energy, which equals m times g times h. In our final, we have no gravitational potential energy because she's at the bottom, and no kinetic energy because our velocity is 0. So it's only elastic potential energy because that's the force of the spring. So we know that it's mg, our mass times gravity, and our mass is 52, and our gravity is 9.8, and our height is the 2.5 meters plus the 0.75 from the compression of the spring, which equals our elastic potential energy, which equals 1/2 k times our x squared, and our x being the 0.75 of the compression of the spring. We're going to solve for the k, which gives us 5,888.71 newtons per meter, which gives us our spring constant. For the second part, we're going to figure how far the trampoline compresses when she's at rest. We know that F net equals 0 because it's in equilibrium, which is shown in the free body diagram, with the mass, with the mg being negative and the force of the spring being positive. So Fs minus mg equals 0. We're going to use Hooke's law because we know that the spring is ideal, and we'll plug the k times L in for our Fs. The k being our spring constant, and the L being the length of the spring compressed. Minus our mg equals 0. We solve for L, which equals mg divided by k, and we get 0.0866 meters, which equals 8.7 centimeters. And this is how far the trampoline compresses when she's at rest.